Hello, welcome to THTV. In today's class, we are going to look at how we are going to solve the question that is being projected on our screen. And let's read it together. The question says that state and illustrate with a diagram the hybridization types in the following compounds. We have C2H4, we have C2H2, and we have C2H6. Right? So it is established that alkanes are sp3 hybridization. Alkenes are sp2 hybridization. And alkynes are what? sp hybridization. So alkanes, as we know, are single bond. Alkenes are what? Double bond. And alkynes are what? Single bond. Now, how do you identify the various compounds given, whether they are alkanes, alkenes, or alkynes? So you identify them by comparing them to their general formula. You know that alkanes, their general formula is CnH2n plus 2. Alkenes are what? CnH2n. Then alkynes, they have CnH2n minus 2. So our concentration is mostly at the hydrogen side because the carbon number may be the same. So we are looking at how we will be able to identify the given compounds, whether they are alkenes, alkenes, or alkynes, and we said we have to compare them to their general formula. So our concentration is what? At the hydrogen side. Now the first one, the hydrogen number is 4, so let's try to see which one will give us 4 using 2 because the carbon number is 2. Now when we put 2 here, 2 times 2, 4, plus 2, 6. So this one, the hydrogen number is what? Hydrogen number is 6. This one, when we put 2 here, we'll get the hydrogen number to be what? 4. And the last one, when we put 2 times 2, 4 minus 2, the hydrogen number becomes 2. So which of them is the hydrogen number 6? So meaning that C2H6 is what? Alkanes. So this one is single bond, alkanes. Then we have the one that having hydrogen number to be 4, which is alkenes, double bond. Then we have the last one, which is giving us a hydrogen number of 2, alkynes. So this one is triple bond. So you identify them by comparing them to their hydrogen numbers, right? So that's how you do it. Now we have been able to identify the various compounds because we said that alkanes are what? sp3. So meaning that this one is sp3. So C2H6 is sp3, right? Now we said that alkenes are what? sp2, alkenes, double bond. So we have C2H4 to be sp2. Then we have alkynes, C2H2. We said alkynes are what? sp hybridization. So we have been able to identify the type of hybridization in the following compound. C2H6 is sp3, C2H4 is sp2, C2H2 is sp. Take note. So we have answered the first part of the question because it says that we should state. So we have stated the hybridization types in the following compounds. Now let's get to the second part, which says that we should illustrate with diagram the type of hybridization. So let's illustrate with diagram. And what happens is so let's start with the first one, which is is C2H4. So we said that C2H4 is having sp2 hybridization, meaning that we are going to have 3 hybrid orbitals at the end of the day. So let's look at the short method to do this. So First, you can first draw the structure for what? C2H4. So C2H4 is something like this. So this is C2H4. So what you do is that you now draw the hybridization state. You represent your carbon. Then this is your hybridization structure. It brought one electron, right? Then the second carbon too brought one electrons. Then you represent this, the first one, then the second one. You quickly represent it. So you quickly represent the third one as this, then the fourth hydrogen bond like this. Now you notice that you use only one of the bond to form the hybridization, so one of the bond is left, so it will break. If it breaks, the carbon will take half or it's one electron, right? And that one, this is how it looks like. It has a dumbbell shape. Then one of the electrons to come on the carbon. So this will bond with this to form what? A pi bond. So double bonds, we say that they have one pi bond, one sigma bond. Now the hydrogen is atomic number 1 and is 1x1. So it is spherical shape. So spherical. That's all. So hydrogen. This one is your hydrogen. So this is the hybridization structure for what? Alkenes. Let's look at the second one, II, which is C2H2, right? And this is the structure of it. It's having triple bond. So one hydrogen. So quickly represent that. This. So we have only one hydrogen here, spherical. One hydrogen. So we are left with two of the bonds, right? We use only one. So meaning that each carbon is having two left electrons that didn't take part, or two left orbitals that didn't take part in the hybridization. So this is how it's being represented. So this will bond with this, and the second one will bond with the second one. So we have pi, then sigma. So your sp3, this one is sp3. Oh sorry, this one is sp hybridization. Sp. So we said that alkynes have one sigma bond, two pi bonds. So at the end of the day, we get 1, 2, 3 of the bonds. So this is how it will look like. Then let's look at the last one. The last one is C2H6, right? C2H6. So one carbon will take how many of the molecular orbitals? 3. So they shared one together. So the carbon shared 1, 2, 3. So hydrogen is spherical, right? So hydrogen. So this is your what? sp3 in what? Alkanes. So this is how you illustrate your hybridization. Thank you so much. Please subscribe, share, like, and comment. Thank you. Bye.